Good afternoon. My name is Kaushik Rajashekara. I am a professor in the University of Texas at Dallas in Richardson, Texas. Today I am going to give presentations on the following three topics: automotive electronics progress, including electric and hybrid vehicle architectures. Here we will talk about the functions provided by the electronics and how they are gradually incorporated into vehicles, leading to electric and hybrid vehicles. The second topic will be on power electronics for electric and hybrid vehicles. Power electronics is an enabling technology for the advancement of electric and hybrid vehicles. Then we will look into commercial electric and hybrid vehicles from few manufacturers such as GM, Toyota, Tesla, and others. These are some of the references you may want to look at. There are books, papers, and internet websites. As I mentioned, the first presentation will be on automotive electronics progress, electric and hybrid vehicle architectures. The first item that was incorporated was radio in 1930s. Gradually, other items such as automotive headlights, wiper control, tachometer, ignition control, engine control module, safety systems, cruise control, and other items were added. The first commercially available electric vehicle was GM EV1 produced by GM in early 1990s. In 1997, Toyota produced the first hybrid vehicle. As you can see from this slide, even in 1940s, the automobiles were using only 30 watts of power. Also, it was at 6 volts, and later it was changed to 12 volts in mid-1950s. In the present automobiles, the power requirement of the accessories are about 1 kilowatt to 2.5 kilowatt and could be more in some vehicles such as high-end luxury vehicles. This slide gives you an idea about how the hardware and the software have changed the architecture of the electronic systems. For example, in 1978, an electronic spark control was taking about 35 square inch, costing about $70. In 1997, after nearly 20 years, its size was reduced to 0.75 square inch, costing only $3. By 2002, this functionality was incorporated into the software of the engine control module with no additional cost and space. It also increased the functionality, quality, and reliability. This slide gives an idea about the growth of vehicle electronics. Over the years, the electronics content in automobiles has grown significantly. For example, in 1998, the electronics content was about $894 per vehicle, including the semiconductors, that was about $168. In 2005, the electronics content has increased to $1,550 and semiconductors were about $325. It is still continue to increase because of adding more and more functionality. The electronics in the automobiles are exposed to harsh environment, and also it depends on the location of these components. These components are exposed to salt, high humidity, brake fluid, rapid temperature changes, oxides of nitrogen, gasoline, oil, and other things. And also the temperature depends on the location of the components. In the passenger compartment, the temperature can vary from -40 to +85 degrees Celsius. On engine compartment, it can be from -40 to 125 degrees Celsius. and the components mounted in the wheel, that is wheel mounted components, have to stand minus 40 to 250 degrees Celsius. In hybrid vehicles, we may want to mount the electronics under the hood. This is because of the packaging we want to ensure so that it is all dense. Also, we want to use engine coolant to cool the motor and power electronics. The components are exposed to temperatures like if they are mounted on the surface of the engine, they have to stand 140 degrees Celsius. And the engine compartment close to the engine itself is 120 degrees Celsius. Of course, the engine oil is 148 degrees Celsius and the transmission oil is 148 degrees Celsius. In an automobile, particularly the modern automobile, has several motors. In some automobiles, there are 30 to 40 motors that may have to be controlled. So we need electronics to control all these motors. These motors are used for example, heated windscreen, engine water pump, engine lubricant pump, electronic engine valve actuation, and so on. So now we will go and discuss about the architectures of the hybrid vehicles and see what are the different types of hybrid vehicles are available and how the electric motors and the engine or the internal combustion engines are combined in hybrid vehicles. In electric vehicle, there is only electric motor that provides the propulsion. The power to the electric motor is coming from a battery, and the battery voltage, which is a DC, it is converted into variable frequency, variable voltage AC. That AC is given to the electric motor to run the vehicle at different speeds. So as I said again, the propulsion is provided purely by electric means. The battery, the power electronics, and the electric motor. In a hybrid vehicles, the propulsion is provided both by the electric motor and also by the internal combustion engine. Depending on the speed, depending on the road conditions, it is possible that at certain instant of time, only the electric motor will be working, and at other times, the motor and the engine may be working together, or only the engine may be providing the propulsion power. A plug-in hybrid vehicle is nothing but a hybrid vehicle. The difference is, in a hybrid vehicle, the battery is charged always on board the vehicle. That means an engine is driving a generator, the generator output is converted into DC, and that DC is used for charging the batteries. In plug-in hybrid vehicles, the battery is also charged externally. That means it is charged off on board the vehicle using the generator driven by the internal combustion engine. And also you can plug the batteries in your parking garage or somewhere wherever you find an electric outlet, like in an electric vehicle. So that is why it is called a plug-in hybrid vehicle. So what is the advantage? Advantage is you can get more electric vehicle range operation by using a plug-in hybrid vehicle. So you don't have to depend on the internal combustion engine and the gasoline that is on board the vehicle to charge the batteries. The batteries are already charged when you leave your house. In hybrid vehicles, there are mainly two types, that is series hybrid vehicle and parallel hybrid vehicle. In a series hybrid vehicle uses two electric machines, one is a generator and one is a motor. The generator is sized for continuous power of the vehicle, or the generator can also be used like a range extender operation. That is, it is used only for charging the batteries. So it is not providing the propulsion power always in parallel with the batteries. In other type of series hybrid vehicle, that is a full series hybrid vehicle, the generator and the battery will be providing the propulsion power at the same time. The motor is always sized for peak power of the vehicle, and the generator is sized depending on whether it is a full-size vehicle or full-size series hybrid vehicle or is a range extender vehicle. If it is a range extender vehicle, the generator is very small one, about it can be few kilowatts depending on the size of the vehicle. Whereas in full series hybrid vehicle, the generator is sized for continuous power of the vehicle. And always the power is flowing from the engine to the generator, the battery, power electronics, the electric motor, all in series. So there can be power loss in the total system. So the efficiency could be lower, and also the range that can be obtained from the battery could be less depending on how the system is configured. You can see the details of a series hybrid vehicle propulsion system. This is shown to emphasize that how much power electronics is required in a series hybrid vehicle. As I mentioned earlier, the engine drives the alternator or a generator. You need the power electronics to convert the generator output voltage to DC to charge the batteries. And the battery output voltage is converted to variable frequency, variable voltage AC using an electric motor. So here there is a power electronics again, and you need to control the inverters. So there is a lot of electronics here, like digital signal processors and FPGAs and other control systems. And also you need power electronics for DC-DC converter, that is to convert the higher voltage battery to 12 volts. The propulsion battery is of the order of say 144 to 300 volts. So you need to step down the voltage to charge the 12 volts batteries. That is what this DC-DC converter does. And also there can be an off-board charger and also an on-board charger. So there are various ways of charging the batteries. In parallel hybrid vehicle, as I mentioned earlier, the propulsion power is provided both by the engine and the electric motor. So it may use one machine for motor and one machine for the generator, or there could be only one electric motor. The motor is sized for fraction of a peak power of the vehicle. The reason is the propulsion power is also coming from the internal combustion engine. The power flows from engine directly through transmission to drive the wheels. So the engine power and the motor power are combined to provide the propulsion. This is another type of parallel hybrid vehicle configuration that is also called input power assist. In this case, you can see from the diagram that vehicle is launched with the battery, that is in a pure electric motor or pure electric vehicle range operation. Motor assists the engine when the transmission is in high gear, and also when the power is not that much required, the engine power or the excess engine power is used for charging the batteries. And engine can operate at either at low speed and high loads, or whenever there is a high power demand is required, and a high power demand has to be met. And also engine can be disconnected during deceleration and also during launch. There is another combination, that is series parallel hybrid combination, that is more like Toyota Prius. It uses two electric machines, a generator and a motor. Motor and generator are sized for fraction of peak vehicle power, and it provides both series and parallel path from engine to drive the wheels. you can see here that engine is directly connected to the transmission. And also the electric motor is also connected directly to transmission, but the motor is getting the power from the generator driven from the engine and also from the propulsion battery here. More or less the similar configuration is used in Prius also and other Toyota hybrid vehicles. Plug-in hybrid vehicle. Plug-in hybrid vehicle, as I mentioned earlier, it runs as an electric vehicle when the battery charge is higher. That is, as soon as you leave the house, you can run it like an electric vehicle. And it switches to hybrid mode when battery power is low and when driver requires more power also. We can also achieve vehicle to grid operation using plug-in hybrid vehicles because when the vehicle is not in use, if there is sufficient energy in the batteries, that can be converted to AC and power can be fed to the grid. And when the battery charge is low, we can use the grid to charge the batteries. This slide summarizes some of the architectures which I mentioned earlier. You can see that there are basically two types of vehicles, series and parallel hybrid vehicles. And also there is a conventional engine where there is no electric motor, and there is an electric vehicle, there is no internal combustion engine. In between, that is having only conventional engine, that is internal combustion engine, or having an electric motor, there are various options. You can use a bigger engine and a small electric motor, that is a micro hybrid, where you can get certain functions such as where at the signal lights you can stop the engine, or when the vehicle is decelerating you can switch off the engine, or also in some cases you can achieve regeneration. So all these functions can be achieved. So this will add to about 5 to 10% in fuel economy. Or you can have a mild hybrid vehicle where the electric motor size is slightly bigger than the micro hybrid and the engine size is relatively smaller, and you can achieve more functions, such as, for example, when the vehicle is accelerating, the electric motor can help the engine and provide more propulsion power. And also during hill climbing, the electric motor and the engine can work together to climb the hill. And there are a few other functions such as diesel, like regenerative braking or the energy capture during regeneration and start-stop operation, and this type of things can be achieved. A full hybrid is like a Toyota Prius where you can achieve a lot more functionalities. Of course, if you don't use an engine, then it becomes an electric vehicle. Same thing, you can have the operations in a series hybrid vehicle, but in this case, the propulsion power is always provided by the electric motor. You can have a range extender type of operation or a full series hybrid operation, which I had explained earlier. That is, in range extender operation, you will still have a very big battery or relatively big battery and a smaller electric generator which charges the batteries. And this generator is driven by the engine. Or you can size the engine and the generator in such a way that in addition to the battery, the generator also provides the propulsion power. Then in that case, you don't need a bigger battery, and also you need to have a relatively bigger generator compared to a range extender type of vehicle. It is possible that you can replace the engine and the generator using a fuel cell. Then fuel cell will charge the battery, and then it becomes a fuel cell vehicle. You can use a smaller fuel cell or a bigger fuel cell depending on the functionalities that have to be achieved. In micro hybrids, the power of the electric motor is in the range of 3 kilowatt to 5 kilowatts, and you can achieve fuel economy of about 5 to 10%. In mild hybrids, the electric motor is rated for about 10 kilowatt to 15 kilowatts and achieve a fuel economy of about 7% to 15%. And also you can combine the internal combustion engine and the electric motor in such a way that the electric motor is mounted between the transmission and the engine. Then it looks like an integrated system. Then it is called an integrated starter generator system. In a strong hybrid like Toyota Prius, the electric motor will have power of more than 20 kilowatt, and you can achieve fuel economy greater than 50%. And also you can have a limited electric vehicle range, a smaller engine, of course it costs higher. So there is an energy hybrid, that is you can have a higher energy storage with longer zero emission range. So these are the various possibilities that you can have in the hybrid vehicle architecture systems. So this slide summarizes how much we can achieve the fuel economy based on the size of the vehicles. If it is a small class vehicles like where the idle stop and that type of operation are achieved, where the electric motor power is less than 10 kilowatts, you can have about 10 to 15% in fuel economy. If it is a mild hybrid, you can go still higher. And in full hybrids, you can go as much as 50% you can achieve fuel economy. So this lecture, I have summarized the different electric and hybrid vehicle architectures. I also talked about plug-in hybrid vehicles. So there are a few questions you may want to look at answering. What is the difference between electric vehicle, hybrid vehicle, and a plug-in hybrid vehicle? So what is the power rating of the electric motors in a micro and a mild hybrid vehicles? So what is the difference between series hybrid vehicles and a parallel hybrid vehicle? So thank you, and we will talk about the other aspects of the automotive power electronics in the next section.